Okay, so we spent 2 days last week doing chemical reaction labs here in class, and you joined your teacher and you had to do them together. So what we're going to do is we're now going to take the information from the chemical reaction lab and we're going to put it together and see the 4 indicators that are going to give us a chemical reaction. There was a little foldable that you should have gotten before you started the video. You should have printed it out. If you didn't print it out, it's okay. What you're going to do then is you're going to make a 4 square on your notebook, and we're going to do some notes. Up here on the top, I put indicators of chemical reaction as my title. So that way I know whenever I have a chemical reaction take place, one of these 4 things is going to happen. And these are the things that we saw in our labs last week. Okay, so the first one that I want to start with is a production of gas. All right, so anytime that we have a production of gas take effect, we're going to have some type of chemical reaction take place. The thing is, though, every time we have a production of gas, we're also going to have some type of temperature change to take place. So those two always go together. Whenever you have a production of gas, you're going to have a type of temperature change also. It's either going to get endothermic, which is where it gets cooler, or exothermic whenever it gets hotter and stuff and it releases the heat. So we're going to kind of do those two together. So the first thing I want you to do is production of gas. I'm going to go ahead and open up my foldable here for you to read it. And what it says is anytime that you have bubbles, you'll have a change in temperature. So it's anytime that you get gas bubbles, it's going to give off some temperature, or it's going to take in temperature. The gas bubbles produce the temperature change that take place. So we're going to go ahead and tie into this temperature change one. And what we have is I'm going to take on here I'm going to put my shield on over my eyes and stuff. And it kind of echoes a little bit, but this way it's going to protect my eyes and everything. And if my students come in, it's okay. I have everything that I'm supposed to have. So we're going to take our test tube and I'm going to put it here. And I'm just going to kind of adjust the camera down so y'all can watch as I do it. All right, so I have my test tube here. I am going to take some hydrochloric acid. So I'm going to take hydrochloric acid. And I'm going to put it in my test tube. Okay. And I put 3 droppers full. Then I'm going to take some magnesium shavings. So I grab some magnesium shavings and I'm going to put them in here with it. All right. So what you should see is bubbles coming off of it. And then you can't see it, but here there's some vapor coming off of it from this. And then when we touch it, it's hot. This one's going to be hot. Now, I'll walk around in class and I'll let all the students touch this one and stuff. And they're just kind of put their hand there and it's just going to feel hot to them and stuff. And I don't know if you can really see, there's some smoke coming off of it. So this is called an exothermic. All right, exothermic means that it releases heat, but you'll see that it gives off the gas bubbles. All right, so I'm going to put this in my chemical disposal bucket, water it down just a little bit, put it in my bucket. Okay. I just added water in there into my bucket and everything so that way it didn't have a big reaction whenever I mix my other stuff. All right, the next one I'm going to do is I'm going to take another test tube and I'm going to take a little bit of vinegar and pour it in. Now, no, this is not the best way to do it, but we're just kind of doing a little demo. I'm going to take some and I'm going to put it in there like that. And then I'm going to take my sodium bicarbonate and I'm going to drop it in. And I'm going to see some bubbles coming off of this one. Now this one isn't as cool and everything, but I got bubbles coming off of it. And when I feel it, this one's cooler temperature, okay? So this is the cool down. This is called an endothermic. That means my temperature is dropping on this one. All right, so it's getting cooler and the students will walk around and they'll feel it and they'll feel that it's getting cooler in temperature. So that's what's happening for this one. So I got gas bubbles out of both of these. One of them gave me heat and one of them gave me cooler temperatures. So you're going to put temperature change as another indicator. And what I did was I took magnesium and hydrochloric acid and I got an exothermic. It made it hot. It gave off that smoke from it. Then I put hydrochloric acid. Instead, I decided to use vinegar. So it's an acid also. And sodium bicarbonate. I put a little piece in it and it made it cold. It got cooler in temperature, which is endothermic. All right, so you don't have to know exo and endo. You just need to know that there was a temperature change. So those two things alone showed me that I got a new substance. I can't go backwards to my original source now. Okay, bubbles happening, gas production, stuff like that, and a temperature change. I can't go backwards to what I originally had. It's not possible for it to do that. All right, so I've got to remember that, and I've got to remember that gives me a chemical change. New substance was made. All right, what I did was I took what I started with and I just rearranged them. My next one that I'm going to have is called a production of a solid precipitant. Okay, so this was last week when we took the milk and the vinegar and we put them together. That gave us our solid precipitant. A lot of the kids said, you know, it looked like chunks and things like that. That's a solid precipitant. Okay, it's two liquids that come together that make a solid. All right, that's a precipitant. I mean, no other way to explain it to you. So I'm going to take my test tube. Okay, and I'll just kind of lower it down so y'all can watch. So I'm on this test tube here. I'm going to take it. I'm going to take my cupric chloride here. And I'm going to go ahead and just give myself, I think we're going to end up needing probably about 4 or 5 of these. 3, 4, 5. All right, so I took my cupric chloride, I put it in there, and now I'm going to take my silver nitrate. All right, now if I look at cupric chloride alone, it's just blue. All right, my silver nitrate, when I look at silver nitrate, it's clear. Well, it's going to be clear. So when I add them together, they make this white foamy thing at the top. And what's happening is, I don't know how well you can see it, I'm trying to show you. You see there's little white chunks that take place here. So it makes my precipitant. I tell my students, and you can see it a little bit in here, I tell them it kind of looks like a snow globe. So what my two liquids did was made a little solid take place. All right, so that is precipitant or solid formation. We like to call it solid formation because a lot of kids don't remember precipitant, but you guys might. I mean, if we use the word enough. All right, so again, all I did was I took cupric chloride and silver nitrate, two liquids come together, they form a solid. It looks like a snow globe. Those are the notes that I put down on there. All right, my last one is a color change. All right, so what I explained in class before the lab and stuff when we did magic milk on day 1. We took the milk and we put food coloring in there, 2 different colors of food coloring, and they swirled around, all right, when we added the soap. That was a physical change because I didn't get a new color to take place, all right? And then we talked about colors that happen naturally. If I put blue and yellow, I'm gonna get green. White and red's gonna give me pink. Things like that, they're gonna give me those colors in nature. It'll naturally happen with the colors. That's not a color change, all right? A color change is when you have a color and it's a completely different color. I use the example of if I had 2 clears and it made it black. That's a color change. What we did with the ammonia in the grape juice, it made it a dark green. That's a color change. I had purple and clear and got dark green. So those are what we call a color change, okay? With that taking place, I'm going to I have my next test tube here. I'm going to take my cupric chloride again, and oops, sorry. I know, it's one of those days, guys, I'm sorry. I'm gonna take my cupric chloride, and I'm gonna put 5 in here. 1, 2, 3, 4, 5. Okay? And then I'm going to take my aluminum foil. So I have a blue, and then I have my aluminum foil. That is silver. And I'm going to put it in here. I'm going to give it a little bit of time to react. And as it does, you're actually going to start seeing that it's going to rust. Okay, so I'm getting a color change take place here. It's starting to change my foil to a brownish color. All right, so that is a color change taking place. I had one color and I'm going to a completely opposite, different color. All right, so then what I have written down here is that you have cupric chloride and aluminum. Put them together, we get rust. That's the color change. When we had the grape juice and ammonia, that's a color change. Now, are these the only experiments we could do? No. So don't think that they're the only ones that we could do. You could have different experiments and different things, but these are just safer ones that we do in class to show these things, and they're pretty drastic, and it happens real fast for us, all right? Click and do your spiral review. If you have any questions, just let us know. Talk to you later.